Hi, I'm Charles, and I'll be presenting you chapter 13.2, question number 9. And the question is, consider the following nonlinear programming problem. Maximize fx equals x1 plus x2 subject to x1 squared plus x2 squared less or equal to 1, and x1 be greater than 0, greater or equal to 0, and x2 greater or equal to 0. And question A, verify that this is a convex programming problem. And question B, solve this problem graphically. The definition of a convex function. S is said to be a convex set, and if any x1, x2 belong to S, then 1 minus alpha times x1 plus alpha times x2 belongs to S of x. And alpha is greater or equal to 0 and less or equal to 1. Or alpha 1 times x1 and plus alpha 2 times x2 belongs to S for all x1, x2 greater or equal to 0. And alpha 1 equals 1 minus alpha 2. So randomly choose any 2 points in the feasible area and connecting any points within the range. We could observe that the line is also in the area. So we say this is a convex function. Here is the feasible area, and these are the points that we randomly choose. And by connecting them, we can also see that the line is also within the range, within the area. And graph. By looking at the constraints, x1 squared plus x2 squared less or equal to 1, we could obtain a unit circle. And given the constraint x1 greater or equal to 1, x2 greater or equal to 0, we could have this. The purple represents the constraints, and the blue represents the feasible area. And since the constraint is a unit circle and x1 equals cosine theta and x2 equals sine theta, and in order to find the max of cosine theta plus sine theta, which is this point, theta is equals to 45 degrees. And then we could see that when theta is equal to 45 degree, x1 equals to 1 over radical 2, and x2 is also equals to 1 over radical 2. So the maximum value of x1 plus x2 is radical 2. And that's the end of the presentation. Thank you.